and who is going to provide. So Chainlink is playing the massive role
Okay.
to handle those financial fluctuations on decentralized platforms.
Okay.
So for all the DeFi applications to be secure,
Yeah.
you need to have these mechanisms, and
Right.
they can only be achieved when you have that information. So Chainlink is providing that price feed information. And it's not only for price feed, I'm just giving an example. You can integrate any API for that.
Okay.
But I'm saying yes, like it will be more easy in future. Like you just don't need to write so many of the code, because it will be something like, okay, you just plug this and things start working. And this Chainlink as a decentralized Oracle platform
Yeah.
is playing the bigger role there.
So we have spoken about the Byzantine practical consensus algorithm. We also touched based on a federation,
Yeah, federated Byzantine
Federated?
fault tolerance.
a federated algorithm. Now I have questions to you about the other consensus algorithm. I've heard of proof of work and proof of stake as well. So would you share some light on those? Maybe let's start from proof of work.
Yeah, so let me try to put it the way they're named. Proof of work, like you have to prove that you're working.
Yeah.
Proof of stake, you need to prove that you have stake in the system or stake in the community or within those people or whatever ecosystem you are in. For the decentralized voting activities and getting rewarded, I will talk about it. But yes, that's the essence of proof of work and proof of stake. Let's understand it
Okay.
like in a real world example, and then we will try to put the same in terms of technology, how they are being used for blockchain.
Okay.
And I will try to cover a little bit of security there. Please remind me if I skip anything. Please keep on
Okay.
poking me if I miss something. Ask
Right.
any of your
Yeah.
questions.
And
doubts if
encryption
you
as
have.
well. We can touch
Yes.
base on a bit of
Okay,
encryption and security.
I will give an
Lovely.
overview of
Yeah.
how it's been used.
Okay.
Let's take an example of like time and work mathematics, where like if somebody does this amount of work in less amount of time, this is why they are inversely proportional, time and work. So if you do more amount of work in less amount of time, you are considered efficient,
Yeah.
right? That's how time work
Yeah.
works. And in terms of that, let's say you have built like a society or a community of, let's say, 100 people, and they are elected based on their efficiency. The amount of work they are doing in a particular amount of time will define their efficiency, and they will be chosen as a leader for a certain amount of time to do a certain amount of or a certain type of task. So for example, I have to put a street light. So that's my task, and who I'm gonna choose out of these 100 people. So you put the proposal there, 100 people participate, and you found the efficient one, and that efficient one is decided to do the job of putting the thing.
Okay.
Similarly, let's take an example in a technology world, like the way Bitcoin works. There are several number of computers who are trying to do some kind of work in an amount of time, and based on that their efficiency is calculated, and one of those computers are chosen to do a transaction. Simple. Now if you look at the particular amount of work, so in one statement it was very easy to understand, but there is a lot of process going on, and let's
Yeah.
go step by step.
Okay.
The work. So computers are doing work.
Yeah.
What work are they doing? So they are
Processing.
given some information, and they are using the information, giving me some kind of result. So what is that job they're doing? They are doing basically, okay, let me think of an example. Like they are doing hashing of the information.
Okay.
So if you, okay, let's understand what is hashing a little bit, and then I'll come back to this. Hashing is something like it's a box.
Yeah.
You give something, and you get a fixed length of output.
Right. Yeah.
And it's going to be different if a different information comes in.
Right.
So the same output cannot be generated from different inputs.
Okay.
One input will always have that as an output.
Okay.
And it's a fixed length size, and it's going to be different if a different input comes in. So let's understand hashing that way. So these computers are always busy doing the same thing to a particular problem. So, but we said they are doing some work. So work has a particular goal.
Yeah.
So why are they doing it? What is the goal? The goal is they are given a problem that, okay, if you give me this within 2 minutes, you are the winner, like you do it in a class. So you give an assignment, and if somebody does it first, you say, oh, you do it. So first and right.
Yeah.
So someone can come first, but they may not be right.
Yeah, the more.
So someone has to be, and someone is coming after this first guy, but they are right. So that's the first right candidate.
Okay.
Right. So this is how in the proof of work
Work, consensus.
concepts,
Yeah.
we use the similar kind of thing where they do hashing as a job, and the goal is to match with something. And the faster they do, they are chosen as the leader to do it. Now there's a little bit of a thing like when these nodes are communicating between each other. You can say, okay, I'm sending information, someone else is sending information, then they can be hacked between those networks and all. So to avoid that, there is a process of encryption. And when I say encryption, so you encrypt the message, so you encrypt the information. So let's say I'm sending you a letter, then I put it inside a cover. So, and you are only allowed to open the cover and read it. So that's a way of I encrypted that in that cover, so no one can read it, and the information passed to the system, and it reached to you.
And that's a public and private keys.
Yes.
That whole
So
mechanism.
yes. So
within
if you compare
encryption.
that with the public and private key mechanism, you need a key for encryption and decryption. But here, I will break it down into two different pieces. I won't talk the technology today, but I'll give you a more relatable example here.
Okay.
So let's take an example of how you log into your Gmail account. You need an email ID and a password. So you can say that password is a private key for you, and your email ID, anyone can send email to you. So your email address is a public key for you.
Yeah.
So it's open to everybody for communication,
Right.
but for accessing any information, you have the rights to use the password, the private key, to
Right.
read the information.
Yes, absolutely.
So that's how this whole proof of work works. Now here comes, I did the job. I need a reward now.
Yeah.
That's a social thing,
Yeah.
isn't it? Like in society, if somebody does well, they are rewarded. So, and if I get more reward, I'll be more honest to these 100 people because I'm doing work. And it's similar with the organizations as well. Like you reward your employees.
Absolutely.
Right, based on performance, based on some benchmarks. Similarly, here also reward mechanism works.
Okay.
And that reward mechanism makes these blockchain very, very, very powerful. The entire concept. So who is keeping this blockchain network active? These 100 people? Yes, these miners. So they need to be rewarded.
Yeah.
Rewarded with what? Okay, they did some
Bitcoin.
job. Yes.
Yeah.
So there is a currency for that to be paid. So like Bitcoin, Ether, we have, but we will talk more in a relatable sense now. But I won't go to the task mechanism part now.
Okay.
So sorry, I lost the flow now.
No,
So these miners need to be rewarded. So they are doing some task, they are getting rewarded. So when this particular thing works in a society or in a community or in a decentralized network, when I say in blockchain, so this makes this very, very, very powerful that people do not try to do illicit activity because they are heavily rewarded for keeping it secure.
Right.
So going forward, security is a question, and this is a secured security, I must say.
Okay.
It's a secured security because this is highly secured because of this reward mechanism. And that brings in the economics and this currency. So it's named as crypto economics,
Right.
and which basically talks about the incentives or the rewards given to the network participants, whatever their role is. I'm a staker, I'm a validator, I'm a miner, I'm a node operator, irrespective of the roles. But there is a process of rewarding your act. Act of doing what? Act of keeping the information right, act of keeping the information correct, intact, secure, safe, private. So for these acts that you are doing in the network, that giving you reward.
Right.
So if you are evaluating a blockchain, so I would say, well, I'm not giving you trading advices, but let's say you are evaluating a blockchain,
Yeah.
then I would say look at the participants.
Okay.
The more the participants, more is the security of the network, and better is the reward mechanism.
Right.
The economics of rewarding the participants. That makes your network more secure, and they
Okay.
won't be ever involved in any illicit activities, because
Okay.
they are not getting, they won't be rewarded that much, and they have to rather put more effort to hack the system,
Right.
so
Right.
that cost more.
Okay.
So this is why this is important. Now I will give you an example of proof of stake. Uh, in relation to that, where you had all the workers and you found a best efficient worker to do it based on their work. Here it is based on the stake.
Okay.
So when I say stake, let's say there is a ecosystem where not everybody is allowed to participate, only the stakers are allowed to participate. When I say stakers, they are participating in the voting mechanism and the consensus mechanism. Let's say there are 20 stakers
Yeah.
who have, let's say I have 10 stakes.
Yeah.
Let's say 10, let's make it as a currency as X. So I have 10X, let's say you are also a participant and you have 20X. So you have a stake in the system. So let's say there are 5 of them or 20 of them, they have stake in the system who are participating in this voting process.
Okay.
They do the similar they do the similar encryption mechanism to pass the information within the network. There the job was to do the hashing. Like the more you hash and the earlier you find the result, you are the winner to mine. But here, the more you stake, you have the higher chance to win, to be a validator for
Okay.
doing that process. So in proof
Right.
of work, if you compare the roles here, their work is to find something. Here, to define something, you need to have stake. There, the winner is the miner. Here, there is a validator who is going to validate the transaction. There, the miner does the transaction, and here the validator does it.
Right. So now, so Ethereum was in a big kind of conversation on. Everybody was waiting for Ethereum proof of stake. So why?
Yeah, it's
why
already
still,
there.
it's still there.
For a long time now,
Yeah.
and
So why would we still use proof of work? Why it's still there when the interest
it depends
was more...
on your use case.
Okay.
If you look at, let's compare the existing ones,
Okay.
Bitcoin and Ethereum, based on their consensus mechanism and
Okay.
the purpose. Basically, the purpose, that's important. Bitcoin's idea is not to build any application on top of it. I won't go to ordinals and NFTs. Let's not go there now. Let's first understand. Here we are just passing value based on the UTXO model, where we are just calculating the unspent transaction output and we are just exchanging the value, and that's how it looks like payment. Not looks like, it is basically payment, where like if I have to give you 10 euros, and then it is somehow unspent in terms of cash, and the same is replicated in Bitcoin digitally. If I look at Ethereum blockchain, it is not only just that, it gives you a platform to build applications on top of the network.
Right.
So that's their power.
Okay.
It is not just propagating a value, it is giving you an opportunity to build applications on top of it.
Okay.
And just with the value, if a network is just exchanging values,
Right.
then it is not not a problem with the congestion. Yes, there is a congestion of the network, but if you are doing application and value like Ethereum is doing, this is why to make it more highly scalable for applications and for payments, we have different layer 2 solutions. We will talk about layer 2 solutions in future podcast, but just to give an idea, the purpose of Bitcoin is different from Ethereum.
Okay.
It's not just based on the consensus mechanism.
Right.
Yes, the mechanism is different,
Yeah.
but the purpose is to have an application and a value. Here, just a value
Just a
exchange
value.
network.
Right. Interesting. That was a very good comparison between proof of work and proof of stake and Bitcoin and Ethereum, that we need both. We need both for different use cases.
Well,
We
there
need
are
both
so many
for
other differences which I did not cover.
Okay.
Like it's like this is just the basic that we need to
Yeah.
just cover. Just to wrap it, just to give
Yeah.
a final thought on this.
Maybe an encryption and privacy? No, no, maybe we covered it all.
I will try to give a little bit of idea about the Bitcoin and Ethereum difference that
Perfect.
I
Super.
made.
If we continue, yeah.
Yes. So to give a more idea, like okay, it's not just those differences which I talked,
Proof
like
of work
the
and proof of
proof of
stake.
stake.
Yeah.
They are different in other ways as well. I'll just give you a quick example of it.
Yeah.
Like when you are building applications on top of a blockchain network,
Right.
so there is a concept of tokenomics. I talked about crypto economics before.
Crypto
So
economics, token economics.
yes. So crypto economics is
Yeah.
is a is a way to keep the reward mechanism running within the ecosystem of those network participants to keep the network highly available because it needs to be available all the time,
Yeah.
highly secured, and keep everything ready for scaling up and the decentralization is working properly. So crypto economics is made for those participants. Tokenomics is for the users of that ecosystem, people who are using, let's say, Ethereum blockchain, where Ether is the
The currency
of
for
the
Ethereum.
network,
Yeah.
and you are building more apps on top of it.
Okay.
So this is why those applications needs tokens.
Okay.
So people who are using, they are not using crypto economics. Crypto economics for Ethereum blockchain is for those stakers, validators.
Right.
So there lies their crypto economics. The token economics for that is when they're building applications on top of it and they're creating a token to interact with different applications.
All right.
And they make it interoperable and whatever.
Wow.
Like in terms of Ether, they keep on exchanging. So token economics work more on the application layer side.
Okay.
And crypto economics work more on the core layer of a blockchain network. So if you compare them, so crypto economics comes 1st in terms of, because it is part of the network.
Yeah.
Tokenomics is part of the application. So application
Okay.
comes quite late. So
Right.
people like sometimes I've heard this, like people little confuse those usage. I feel so. But that's my understanding of crypto economics and token economics.
Interesting. So that means it's another episode to cover on crypto economics, token
and,
economics. It's
crypto
more to get more
economics.
deeper into it.
Well, we can, yes, we can do
Yeah.
that. Yes,
Yeah.
absolutely.
NFTs, oracles,
Yeah.
different blockchain,
Yes.
blockchains, Ethereum,
Yeah, we can.
Bitcoin,
Yes, yes,
Avalanche,
yes,
Solana.
yes,
So there are
yes.
so many different comparisons.
I would say something like this crypto economics is even better with Chainlink version 2 now. So they have
Okay.
launched a Chainlink V2 paper, V2 white paper.
Okay.
And the crypto economics is more focused there.
Okay.
Yeah, and the ideal way of keeping a network secure is to reward more participants.
Right.
More they are
More
rewarded, they are more active to
More
keep the
trust
network.
and
Yes,
yeah.
to build
yeah.
the trust. So
Build the trust. Okay.
That's
That's
important.
fantastic. And
All right.
and Baba, so what's so yes, so do you trade? Are you into crypto trading, into digital assets?
Yes, I have done a bit in past, but I don't do that right now
Okay.
because I spend more time nowadays to understand them rather than just doing the trading.
Trading, yeah.
But
okay.
yeah, so I would say the way I used to do was to understand more about, like, more about the utility of the, if it's a new token.
Utility, definitely.
Yeah, and what are the different, like, I will focus more, or I'll talk more about
The
it
use
in
case,
the tokenomics.
probably. Oh, okay.
So you need to understand tokenomics properly if it's an application built on any of the blockchain.
Okay.
And if it's a new blockchain, then I more focus on the way they have implemented consensus mechanism
Okay.
and the participants and how scalabilities and why that network is built for. Like
Right.
there are several use case. I would just okay. You asked me this question,
Yeah,
so
yeah,
I got
no,
a
no,
different
that's
thought.
perfect. Let's go-
So
we'll go with
I
that.
think I should talk about it a bit.
Yep.
If you are looking at a application and if you're looking at a network, so there are a few concepts in DeFi which you need to have a knowledge on it. It's
Okay.
just not like if you are trading. Okay, there are mathematics behind that probably, which I don't understand. Probably that trading maths, but I understand the. I try to understand the product. I try to
Okay.
understand the project. So that's where I got the knowledge and where
Yeah.
I did my masters and all this stuff.
Yeah.
So it's basically you look at how secure the network is. So I will take an example of Chainlink and I will explain that
Yeah.
why they are so secured. Because the participants, the way the crypto
Okay.
economics is designed to keep
Right.
the network highly secured, that makes them quite popular in the Oracle market.
Okay.
And
Right. Good to know. Yeah.
and if you look at the public permissionless blockchains like Ethereum, uh, their security lies on all the stakers because of the way proof of stake works and the number of stakers. That's their pillar because every network's pillar is consensus, which we talked. Proof of work, proof of stake. There are many to it, like Byzantine fault tolerance
Yeah.
techniques. There are proof of delegated proof of stake. There is proof of elapsed time.
Okay.
Uh,
Wow.
there is proof of history, I think, and proof
Okay.
of capacity. Proof of capacity is a combination of different things. So, there are like several way of maintaining the consensus within the network. So, my point is, if you are evaluating a network, it's easy sometimes to evaluate. For your use case, or if you are working in any of the business, if you want to transform it and you want to decide a network. But if you are deciding on an application, on a token, it is even tough
Yeah.
because you have to evaluate two things. One is the application, the goal of the what's that business is all about, and the tokenomics.
Yeah.
And you have to understand the network on top of what network it is being built, and you need to
Okay.
understand the crypto economics there. So there are like so many tasks to do if you are evaluating a token project or
Right.
a network project.
Right.
For your
Okay.
trading purpose or
Yeah.
whatever purpose. But yeah, these are basic tools, I would say.
Okay.
Don't just look at those numbers or
Okay.
charts. Try to understand the ideology behind this, the
Right.
philosophy, why they're doing it.
Philosophy
Philosophy.
of blockchain and philosophy of decentralization.
Yes.
Lovely.